This section 3.2, just let me make a revision of what we did yesterday. Okay, so we talk about the polynomial function, we talk about the degree of polynomial function, we talk about the monomial, binomial, trinomial, right? And we also talk about the end behavior of the polynomial functions. Okay, so let me take a function here, any polynomial function. So let's consider we have a f of x equals to, okay, let me take an example from the book here. Okay, 2x cubed minus 18x. So we have 2x cubed minus 18x. This is, now at first, is this a polynomial function or not? Yes, okay. And how do we know? We check the exponent of the input, right? And if the exponent of the input is whole number or a positive integer, then it's a polynomial function. We have a 3 here and we have a 1 here. Both of these are a whole number, so this is a polynomial function. Okay, now in this polynomial function, we have two terms here. This is 2x cubed is the first term, negative 18x is the second term. So what is the degree of the first term here? So when we are talking about the degree, it's a exponent, right? Or sum of exponent of every variables in that term. So in this term, we only have one variable and its exponent is 3 is the degree. Similarly, this term has a degree 1. Okay, so these are the degree for each term. Now, when we talk about the degree of a function, what is the degree of a function here? The degree of a function is the highest degree. So 3 is the highest degree and this 3 is a degree for this polynomial expression or polynomial function. Okay, and what do we call the term with a highest degree? We call this as a leading term. Okay, and the coefficient of the leading term is the leading coefficient, right? And we also had the leading term test. We also used the leading term to test or to find the end behavior of the function. It means when we have our input x very large, positive infinity, or when we take our input very small, like negative infinity, we can know or we can find how the function behave on the right end or left end with the end behavior test. Okay, and according to that, if we have a even degree, okay, let's say we have a even degree, so we use n to represent the degree of a function. Okay, if our degree is even and the coefficient of leading term an, this is the coefficient of leading term, and if this coefficient of leading term is greater than 0, the graph that we have on the left side, this is the graph that we're gonna get on the left side, and this is the graph that we have on the right side. Okay, so this is the graph that we get on the right side, and we are not worried about what happens in the middle. Okay, so this leading term test, it gives us the behavior of a function on the left end and on the right end. Okay, left end means when we choose our input very small, this is the function that we're gonna get. Okay, when our input is very large, this is the graph that we're gonna get. It means our function goes all the way to the positive infinity. Okay, next, if the degree is even but the coefficient of leading term is less than 0, if our coefficient of leading term is less than 0, then what would be the end behavior? It flips, right? So but the degree has to be still even. Okay, the graph is, this is the graph we're going to get on the left side, this is the graph we're going to get on the right side, and we don't want what happens here. Okay, and the next we had, if the degree of a function is odd number like 1 3 5 7, and the coefficient of leading term an is greater than 0, the graph that we're going to get on the left side, this is the graph we're going to get on the left side, and this is the graph that we're going to get on the right side. Okay, we are not interested here. Okay, similarly, if the degree is still odd but the coefficient is less than 0, an is less than 0, then we're going to have this type of graph. This is what we have on the left side and this is what we have on the right side. Okay, so this is the end behavior. And if you are asked to write down the end behavior of a function, you can use a graph or you can just write in a word. Like end behavior means like you are writing when your x goes to infinity, when your x goes to infinity, what happens to f of x? That's what you are writing. When you choose your x as a negative infinity, what happens to the f of x? That's the end behavior. Or you can always use this graphical way to answer your question. Okay. Now for this function, now let's find out. So for this function, our degree is 3, right? So we go for the odd degree. So this is the odd. And the next, we take the coefficient of the leading term. The coefficient of leading term is 2, which is positive. So we have an odd degree and the coefficient is positive. It means this is the graph that we're going to have for this function. So the end behavior for this function is, so this is what we get on the left side and this is what we get on the right side. Okay, so this is the graph that we're gonna get for this function. Okay, so this is what we did in our SRS class. Do you have any question up to here? Okay, now if so, now let's go ahead and do this example here. So we need to find the real zero. Okay, we need to find the real zero of this function. So we have this function, polynomial function, and the corresponding x-intercept of the graph of this function. So we have a polynomial function and we are looking for the real zero for this function. Now we did find the real zero for the quadratic function. Now what does it mean by the real zero? What are we trying to find here? Now, does it mean that we're gonna use 0 for every x, or what is the real zero? So what are we finding? Are we finding x or are we finding f of x? Any guess? You have the two options. Are we looking the input or are we looking for the output? Okay. Now, so whenever we are looking for finding real zero means we are finding our input. Okay, every time if you are finding the real zero, then you are finding the input x. Okay, we are finding the value of x such that our output is 0. It means we are looking for the x which give us output equals to 0. Now for this function, can you give me a number, any input number for x such that our output is equals to 0? Can you do that like on our head? So we have 2x cubed minus 18x. Any number that give us the output equals to 0. You choose the input. Okay, so this is a polynomial function and this function has all real number as a domain. Okay, so you do have option all real number. Now what is that number, what is that input whose output is 0 for this function? Give me a one number whose output is 0. Sorry, yes, whose output is 0, yes. 0, like if we substitute 0 for every x, we get 2 times 0 cubed minus 18 times 0, that is 0, right? So 0 is one of the real 0 for this function. So every time, okay, so when you see this finding real 0, or in our, I think, last section of this unit, there is a complex 0 also. So every time if you are asked to find 0 means you are finding the input, you are finding the x. Okay, so finding real 0 means you are finding your input. Okay, you are asked to find what is x such that your f of x is equals to 0. So we are looking our input, okay, which give us output equals to 0. Okay, so now here we are looking for a real 0, and to be a real 0, the output has to be equals to 0, right? F of x is equals to 0, equals to 2x cubed minus 18x. So we are finding the x such that this equation is equals to 0. Okay, now this is our equation. Now how to, okay, let me rewrite this equation. So we can rewrite this as a 2x cubed minus 18x equals to 0 is same thing, right? Now how do we solve this equation? So finding the x means we are solving this equation here. Yes.
Divide both sides by -18, then divide both sides by 2, and then...
So divide both sides by -18. Okay, what happens if we divide both sides by -18? We're going to get the fraction in the first term. So that's going to be more complex here. Okay, now once we have the equation, so once we have the equation, we have to use the factorization here. Okay, so when we had a quadratic function or when we had a quadratic equation, we use the factorization, we use the quadratic formula, and we use the completing the square method. Okay, so every time if you are asked to solve the equation, factorization is the easiest way. Now is there any way we could factorize our left side? Do we have any common factor in both of these two terms? 2x. So let's factor out 2x. So let's factor out 2x. This is the common. So if we factor out 2x from 2x cube, what is left there? Okay, and how do we know that? So we divide this 2x cube by the common factor, right? 2x cube divided by 2x is x squared. And if we factor out 2x from negative 18x, what is left? Minus 9. So negative 18x, so you divide negative 18x by the common factor 2x. So negative 18x divided by 2x, that is minus 9, equals to 0. Okay, now here, so we have this number 2x and we have another number x squared minus 9. Okay, and what sign do we have in between these two numbers? Product, right? So we have product of two numbers is equals to 0. And when does this happen? So you have two different number, but their product is equals to 0. So what should be the condition that this product of two number is equals to 0? What has to be true here?
One or both of them has to be 0.
That's right. That is the only case, right? So if one or both number is 0, then only we get the product equals to 0. That is the only condition here. Okay. Otherwise, there is no any way that we could get the product of two number equals to 0. So when you have the product of two number or like product of any more than two numbers, then at least one of that number has to be 0. Okay. It can be first number or a second number. So if that is the case, what we do here is that we set each factor. So this is our first factor. So we set each factor equals to 0. So we have 2x equals to 0. And the second factor is we have x squared minus 9 equals to 0. Okay. So once you have complete factorization on the left one side, or once you express your one side of your equation in a factor form, you set each factor equals to 0. Okay. Now this is our linear equation. How do we solve for this equation? We divide both sides by 2, right? So let's divide both sides by 2. 2x divided by 2, that is x. 0 divided by 2, that is 0. So x is 0. Now for the next, so we're gonna use our square root principle. So let's add 9 on both sides. So we are solving for x. And we get x squared, these two cancel, equals to positive 9. So the next thing, we need to get rid of this square. And how do we get rid of this square? So we get x equals to plus or minus, do not forget plus or minus, square root of whatever you have on the right side. We have 9. So x is equals to plus or minus, square root of 9 is 3. It means x is positive 3 or negative 3. So these 3 are the real 0 for this function. So x equals to 0, x positive 3 and negative 3. So when we choose our input to be these 3 number, our output is always 0. And if that is the case, we call these inputs as a real 0. Okay, so finding real 0 means we are finding inputs that give our output equals to 0. Okay, so do not substitute your x equals to 0 here. So when you are finding 0, it's not that you are substituting 0 for every x. You are finding the x, okay, that make your output or that give your output equals to 0. Okay, now these are the real 0. Now the next, we also need to find the x-intercept. Now how do we find the x-intercept for this function? So how do we find the x-intercept? So finding x-intercept means we are finding the point on the x-axis or a y-axis. We are finding the point on the x-axis, right? And every point on the x-axis has one thing common. And that, what is that common thing? Y is 0. So when we are finding x-intercept, we substitute y equals to 0 and we solve the equation, right? Now for this function, what is y? F of x. And we already substituted y equals to 0 here, right? See, if you are finding the x-intercept, means you are doing the same thing in order to find the x-intercept here. It means that real 0 and the x-intercept, these are the same thing. Okay, so finding real zero means you are finding the x-intercept, or finding x-intercept means you are finding the zero of this function. So whenever you are asked to find real zero, you are finding the x-intercept. You substitute y equals to 0, you solve for x, and the solution for the x is the x-intercept, or it is the real zero. Okay, these two are the same thing. So real zero and x-intercept are the same thing. If we can just write our x-intercept in a point form. Okay, like if you want to write x-intercept, so 0 0 is the 1 point, right? The other point is, so your x is 3, so 3 is 0, y is always 0, and negative 3 0. So these are the x-intercepts. See, y coordinate for the x-intercept is always 0, or you can simply write 0, positive 3, negative 3 as the x-intercept. You can use both x and y coordinate, or you can use the x value for the x-intercept. Okay, so every time if you're asked to find the real zero or x-intercept, it's the same thing. Do not get confused. You substitute 0 for the function output and you solve for the input. Okay, all right, now let's go to the next here. So in the next here, we need to draw a graph of the polynomial function, and here are the 5 steps that is given to us. So let's do this in this example. Okay, the very first step here, so we have the example here. The function is x cubed minus x. We need to graph this function. Now the very first step is that determine the end behavior of the function. Now this is the function here. So we want to know the graph of this function on the left end and right end. That is the end behavior. Okay, so finding the end behavior means we want to know how the function behave on the left side and the right side. Okay, now for that what we need the degree of the leading term. So here, which one is leading term? What is the leading term for this function? X cube. The term with the highest degree is the leading term. Okay, and what is the degree of that leading term? Is odd, right? So the degree is odd. And what about the coefficient of leading term? What about an? Is it positive or negative? The coefficient is, if it looks nothing here, but it's 1, so it is positive. If this is the case, we know the graph looks like this on the left end and this kind on the right end. Okay, so this is our end behavior for this function. So you find the degree of the leading term is odd, the coefficient of leading term is positive. So this is the graph. So this is the very first. So we go, so like when we have the final graph, the final graph has to look like this. So we must have this part of a graph on the left end and this kind graph on the right end. Okay, this is the first step, finding the end behavior. Next step, we find the y-intercept and plot it. We find the x-intercept of the function. Okay, now let's find the y-intercept for this function. And how do we find the y-intercept? What does it mean by finding y-intercept? We are looking for the y value when x is equals to 0. Okay, so for y-intercept, every time you are substituting x equals to 0, so f of 0 equals to 0 cube minus 0, which is 0. So our y-intercept is 0 0. So this is the y-intercept. It means the graph crosses y-axis at this point. Okay, so we need this point to plot here. The next, we find the x-intercept. So let's find the x-intercept. And for x-intercept, what do we substitute? We substitute output equals to 0, y equals to 0, or f of x equals to 0. So we substitute f of x equals to 0 in the function. So we have 0 equals to x cubed minus x. So let me rewrite this as x cubed minus x equals to 0. So this is the equation. We use the factorization method. The very first step, do we have any common factor? X is the common factor, right? And when we factor out x from x cubed, we have x square minus, when we factor out x from minus x, we have minus 1 equals to 0. So you are just taking each term and dividing by the common factor. Okay, so x cubed divided by x is x square, negative x divided by x is negative 1. So you take each term and you divide by the common factor, you get what to write inside the parenthesis. Now here we have the two number and their product is 0. It means either first number or second number has to be 0. So we set each factor equals to 0. So we set x equals to 0 and x square minus 1 equals to 0. So we already know 1 x intercept is 0. Now for the second equation, we can solve this. So we add 1 on both sides. So these two cancel. So we have x square equals to positive 1. In order to get rid of square, we get plus or minus square root of whatever we have on the right side, that is 1. And this is plus or minus square root of 1 is 1. So x is 0, positive 1 and negative 1. So these three are the x-intercept. Yes.
When it gets a difference of squares like that, can we just put like x plus 1 times x minus 1?
Yeah, at the end you're gonna get the same thing, okay? So you can still factorize x square minus 1 as a x plus 1 times x minus 1. Then you set each factor equals to 0 and you end up getting this one, okay? So you can do that. So these are the, now here x-intercept means at this point the graph crosses the x-axis, right? So the next, what is our next step? So it does tell us to find the x-intercept and graph, okay. These points will divide the x-axis into smaller intervals. Okay, now let's draw our x-axis and y-axis. So this is our y-axis, this is x-axis. So this is origin. We know 0, 0 is the y-intercept, right? So the graph crosses at this point. Now next is x-intercept, positive 1. So this is positive 1 and negative 1. Now these x-intercept divide our x-axis into how many part here? So we have 3 x values, negative 1, 0 and positive 1. So this is one part of the x-axis, okay? So we have this part here. So we have this part here and we have this part here. So we use our x-intercept to divide our x-axis, okay? It means we're gonna get a different graph in each interval, okay? We need to know how the graph looks like in each interval, okay? Now let's see what is our next step. Then we find the sign of the value of function for test value x in each of these interval. Okay, now here once we have this interval, we choose any number from each interval. Okay, it doesn't matter what number you choose. Okay, we choose any number on this interval. Okay, now for this first interval, what number do you want to choose here in this interval? What number do you want to choose? Can you choose any input here, any number in this interval? Choose any number. Negative 4. Okay, let's go with negative 4. So we choose negative 4. You can choose any number, okay? Now we have this second interval. Okay, what can you just choose one number in this interval? What number do you want to choose? So we want a number in between negative 1 and 0. Negative 1/2, okay. So let me just write negative 0.5. So then in this interval, let's use positive 1/2, right? So positive 0.5. And in the last interval, let's go with positive 4. But you can choose any number, okay? In this interval, so we choose any number. Now these are our input. Now once we have this number from each interval, now we check what is the sign of the function, or we will check where the function lies, whether the function is above the x-axis or below the x-axis. How do we know whether the function is above the x-axis or below the x-axis? So we have an input negative 4, right? Now for this input, how do we know whether the graph is below x-axis at negative 4 or above x-axis? How do we know that? Yes. Not the end behavior. So negative 4 is the input, right? We choose negative 4, negative 0.5, positive 0.5 and positive 4 from the x-axis. It means these are the input. Okay, so we find the output for each function, and if our output is positive, it means our graph is above the x-axis. Output means y value, right? Y coordinate. So we have our y coordinate positive above the x-axis, right? And negative below the x-axis. So for each of these input, we find the function. If it's positive, the graph is above the x-axis. If the output is negative, the graph is below the x-axis. Now at negative 4, let me write our function. Our function is x cubed minus x. Now when our input is negative 4, is our output positive or negative? We substitute negative 4 for every x. Let's see. So cube of negative 4 is negative 4 times negative 4 is positive 16, right? Positive 16 times negative 4 is negative 64. Negative 64 minus minus 4, that is negative 64 plus 4. So we get negative 60. It means our graph is below the x-axis. So our graph from this point negative 1, our graph goes below the x-axis. Okay, it doesn't matter what number you choose. On the left of negative 1, you always get negative output. It means your graph goes below the x-axis. Okay, now let's see what happens at negative 0.5. Now we substitute negative 0.5 for the function. So what would be the function? Is it positive or negative? So let's substitute. So we have negative 0.5 cube. Okay, negative 0.5. Okay, let's use a fraction. Fraction gonna be easy. So negative 1/2 times negative 1/2 is positive 1/4, right? Time negative 1/2 is negative 1/8, right? So we have negative 1/8 minus negative 1/2. So that's a negative 1/8 plus 1/2. Do we get positive or negative? We get positive, right? 1/2 is 0.5 and 1/8 is less than 0.5. So we get positive. It means our graph goes above the x-axis. Okay, so somewhere here, right? So our graph goes above the x-axis and come back to this x-intercept. It means because at 0 the graph crosses x-axis, so it has to come back to the x-axis. Okay, so once we know this x-intercept, okay, once we know this x-intercept, it means that the function has to cross or toss this x-axis. Okay, so in between these two numbers, if you take any number, we always get the positive output. Now let's check what happens in between these. So let's take 0.5 for every x. So we have 0.5 cube, which is 1/8 minus 1/2. We get negative or positive. 1/8 minus 1/2, we get negative. It means our graph goes below and it come back to negative positive 1, so it goes down. Okay, you don't need to be exactly same. Okay, if you have close enough, then it's. Now let's check at 4. So if our x is 4, 4 cube is 64 minus 4, that is positive 60. So the graph goes all the way this way. And let's compare with our end behavior. See, so on the left end, so our graph we have pretty similar, and this is what we have on the right end. Now this graph looks pretty similar here, right? They have the same end behavior. Okay, and if you have your final graph similar to this your end behavior, then you have the correct graph. Okay, these are the steps here to graph any polynomial function. Okay, we don't want to be precise here. If you have a close enough graph, you get the credit. Okay, it's good. We just want to know the graph of this function is similar to this one. Okay, let's practice. Let's do one more. Okay, so so let me take, okay, let's not take a cubic function. Let me go with a different function. Okay, so here we have a function. This is 2, 3, 4. Okay, so let me do number 52. I'm not sure this is your homework or not. Has anyone already take what homework we have on your exercise? Okay, can you just pick one number? I'll do the same one. So I didn't just mark what number is your homework. 64. Okay, 64. Oh, 64, they have a graph here. So it's a different problem. So 91. Okay, 91. So we have this, use this information to graph the function. Okay. Let's do this one. We do have an easier way, like we do have a couple of topics to cover. So let's use this concept here. So number 91. So we have a 91 here, and the function is g of x equal x plus 1 square time x minus 2 time x plus 3. Okay, this is the function. This is the polynomial function. Okay, now the very first step is we need to find the end behavior. Now we have the function in a factor form. Our function is not in a general form. Now how do we find the leading term here? So if you have your function in a factor form, how do we find the leading term? That's help us to find the end behavior, right? So we need to know what is leading term here. So for that, so you are not required to expand all of these, okay? So what you're going to do is that, so we have a square here, right? So when we expand this expression, we get x square, okay? So we have x square from here, multiplied this x. So x squared times x is x cubed, multiplied x. So x cubed times x is x to the power 4. So x to the power 4 is our leading coefficient, okay? We already have the factor here. If you want to like multiply and just expand, you can just do that, but you are not required here. Okay, so you just multiply the first term of each factor and you get the leading term. Okay, now you have a square here, and the reason I take x square is that we can just rewrite this as a x plus 1 times x plus 1, right, times x minus 2 times x plus 3. Are these two same or different? These are same, right? So you just multiply the first term, x times x, x squared times x, x cubed times x, x4. So this is our leading term. Okay, the degree of this leading term is odd or even, is even degree, and the coefficient of this leading term a n is greater than 0 or less than 0, greater than 0. The one, we have 1 here. And if this is the case, our graph on the left is, this is the graph, what are you going to get on the left? We know how it looks like on the left. So this is the graph, and this is the graph on the right. So this is the end behavior. So you are not required to expand here. You multiply each first term of each factor to get the leading term. Okay, now this is the end behavior. So the graph looks this on the left side, and the graph is this on the right side. The next step is we find the y-intercept. So let's find y-intercept for this function. So let's find y-intercept. And finding y-intercept means, what do? We substitute x equals to 0. So we substitute x equals to 0 in this function. Now I think we can do this on our head. So 0 plus 1 times 0 plus 1, that's 1 times 1. 0 minus 2, 0 plus 3. So we have 3 times minus 2, minus 6 times 1 is negative 6, right? So we get negative 6. So our y-intercept is, so you substitute 0 for every x. Okay, so 0 plus 1, 0 plus 1, 0 minus 2, 0 plus 3. So for every x, you're going to substitute 0, and we get negative 6. So our y-intercept is 0, negative 6. So this is the y-intercept. It means the graph touches or crosses at this point on the y-axis. The next, let's find x-intercept. And to find the x-intercept, what do we substitute? We substitute f of x or we have a g here, g of x equals to 0. So we have 0 equals to x plus 1 times x plus 1 times x minus 2 times x plus 3. Okay, how do we solve this equation? That's right. So here, so if we see carefully, so we have this number times this number times this number times this number equals to 0. So we have the product of these 4 different number equals to 0. And the only condition that we need for this is that we need to have at least one of this number has to be 0, right, to get the product equals to 0. So we set each factor equals to 0. Okay, so we set each factor x plus 1 equals to 0. We set each factor equals to 0, x minus 2 equals to 0, x plus 3 equals to 0. We are not required to factorize here. It's already in a factor form. So once you already have a factor form, you set each factor equals to 0. Okay, if this is the case, then only their product is equals to 0. Now we can solve this equation. These are linear equation. So we subtract 1 on the both side. For this equation, we subtract 1 on the both side. For this equation, we add 2 on the both side. For this equation, we subtract 3 on the both side. So we have x equals to negative 1. We get the same number here. X equals to negative 1. X equals to 2. X equals to negative 3. So we have this x-intercept. It means the graph crosses or touches the x-axis at these different points. Now let's make our x-axis and y-axis. So we have x-axis, we have y-axis, this is 0. Now let's plot this x-intercept and y-intercept. So our y-intercept is 0, negative 6. So this is y-intercept. Okay, this is 0, negative 6. Let's plot our x-intercept. So negative 1. So our x-intercept is negative 1. Then negative 3. So negative 3 and positive 2. So this is x-intercept. And these x-intercept divide our graph, our x-axis in different intervals. So this is the first part here, right? So we have the second part, second interval here. So we have this third interval, okay, and we have this interval here. So we use those x-intercept to divide our x-axis, and in each interval we're gonna get a different graph. Okay, we get a different graph. Okay, now the next step is we choose any point from each interval. Okay, now let's take first interval. So what number do you want to choose from the first interval? So any number on the left of negative 3. So let's go with negative 4, right? So what number do you want to choose in between negative 3 and negative 1? Negative 2. Okay. What number between negative 1 and 2? Let's go with 0, right? That's some famous number, 0. Let's choose 0. So, in the last interval, we can choose 3. Or you can choose any number. Okay, it doesn't matter. From each interval, if you want to go with a fraction decimal, it doesn't matter. Make sure that number is in between this interval. Now, once we have this, we check the sign of the function at this number. So we want to know whether the output is positive or output is negative. If output is positive, we draw a graph above the x-axis. If output is negative, we draw a graph below the x-axis. Okay, and we already know that our graph looks this kind on the left, right, and this kind on the right. We already know this one, but still we can check at negative 4. So what happens to our output when our input is negative 4? Let me write this function here one more time. So our function is g of x is x plus 1 times x plus 1 times x plus 3 times x minus 2. So if your x is negative 4, so we get this negative, right? So when your x is negative 4, negative 4 plus 1 is we get negative 3. Okay, we are not worried about like what number we get. We just want this sign. So this negative 4 plus 1 is negative. Negative 4 plus 3 is negative. negative 4, negative 2 is negative 6. So negative times negative, negative times negative, positive times negative, negative times negative, positive. So we're going to get positive. It means our graph go above the x-axis. So you draw the graph above the x-axis, and on the left hand, this is the graph here. So we're going to draw the graph like this, because we already know here on the left hand the graph has to look like this, right? And from this you can just draw the graph on the right side, because we're going to get the same graph here. So we can draw this part of a graph on the right side. Okay, we already know from our end behavior test. Now we want to know what happens in between here. Okay, now let's go with negative 2. If we choose x equals to negative 2, what happens to the sign? So negative 2 plus 1 is negative, negative 2 plus 1 is negative, negative 2 plus 1 is positive, negative 2 is negative. So we have negative times negative, positive times positive is positive, times negative is negative. So negative means we have the graph below the x-axis. So we draw the graph below the x-axis and come back to our negative 1. So you get the graph, okay, it come back to the x-intercept, okay. Now let's choose 0. So when our x is 0, 0 plus 1 is positive, 0, so you are substituting for every x, okay. 0 plus 1 is positive, 0 plus 3 is positive, 0 minus 2 is negative. So positive times positive, that is positive times positive, which is positive times negative is negative. We get negative. It means our graph is below the x-axis.
When you go down to the
Oh.
6, that's the y-intercept.
Oh, that's right. So it comes all the way to this. We do know what is the y-intercept, so we can't ignore this one. Since it's a negative, so you draw all the way to this negative 6. It crosses y-axis at this point and go back to positive 2. Okay, so this is the graph for this function. Okay, let's do this much for today. If you have any question